question number 11 on the practice test. And again, this video is only going to talk about the free response questions. I've already uploaded a multiple choice question answer key, so you can look at that on the videos as well. But in this particular question, number 11 talks about a headline Katie, is a headline in a local newspaper that announced that video game playing can lead to better spatial reasoning abilities. And that just means being able to visualize things and being able to make sense of how they relate in space. The article reported that a study found statistically significant differences between teens who play video games and teens who do not, with teens who play video games testing better in spatial reasoning. Do you think the headline was appropriate? Why or why not? Why or why not? If the answer is no, why can I not say that? I heard you say something about correlation doesn't imply causation. That's sort of like what we're saying here. But what's the only way that we can say one causes the other to happen? If it's a what? Experiment. Is this an experiment? Did we have a control group? Did we have treatment? None of that. Because it's not an experiment, we can't make that appropriate statement. We can't make that claim. Okay? So no, this was not an experiment. Only well-designed experiments can have an outcome where you can say that one causes the other to happen. Okay? Yes, sir. Yeah, because it's not a bivariate data set. So this is specifically talking about an experiment. Okay? Or the fact that it was not an experiment, really. Well-designed experiments can show causation. Correlation alone doesn't, but well-designed experiments can. Okay? All right, number 12. So this one had some discussion because of the number of treatment groups and things like that. We're looking at college spending habits. Okay, you guys are going to be in the near future, some of us more sooner than others, are going to be in college, and we're going to be on our own for the first time, and we have to be careful of how we spend our parents' money or the government's money or your loan money or whatever it happens to be. But a consumer group wants to see if we can improve the spending habits of our college students, and so they proposed a program where they assigned 3 different courses, students to 3 different courses on spending habits. So what are the experimental units? What's another word for that? Subjects. Very good. So this is another word for subjects. So who is getting the treatment? The college students themselves. Very good. Okay? So the students in the economic class. And those are the people that they were chosen to go into this experiment. Good. I probably would not give you full credit if you just wrote college students, because not all of the college students were in the experiment. The only people that were subjected to the actual treatment were the people in this class. So I want you to be specific. It's a good question. All right, how many factors are there? What is a factor? A factor of an experiment is something that I control, that the experimenter controls. So, and that's what we're kind of trying to measure against, right? So what am I changing in this experiment? The courses, right? We're changing that. So there's really one factor. The factor is the new course, okay? So there's one factor. The problem is that how many levels of the factor is there? 3. So there's one factor with 3 levels. The experiment that the example that I used in class that had multiple factors would be, if you remember the example where I had with the garden, and I said that we can control the amount of sun it gets and the amount of water it gets. Those would be 2 separate factors. They could have multiple levels where I could feed them once a week, twice a week. I could water them once a day, twice a day. But the factors would have been the 2 separate things. Here, there's only one factor. It's just the course, the new course. But there's 3 options. So there's 3 levels. Now, question C, how many treatment groups are there? Now, I kind of like the discussion I had over here at table 3, because we can see right away that there are 3 groups. There's 3 new courses to have. So we know there's at least 3 treatment groups, right? What's the possibility for there to be a 4th treatment group? The control group. And it's not clear in this whether there is or is not one. So to me, I think the most appropriate answer would be 3 treatment groups with 1 possible control group if it doesn't state it, okay? When I say control, I mean there's no treatment. There's no, so we could assign no treatment. Okay. So the answer in this case really should be 3, but I can make an argument for could there be 4, because if there was a group of people that they just said, we're not going to give you a new course, then I would agree with that. I don't think this question is very clear about that. So I would accept either the answer of just plain old 3, or if you had said as long as there's a possible control 4 would have been an explanation. But you had to explain it. Okay? Like your haircut. That's good. All right. D, what's the response variable? What am I measuring? The spending habits. Yeah. Okay. Very good. Did they spend more money, or not? Good. Any questions about that? All right, question 13 was an actual simulation. Okay, so we have to figure out what we're looking at here. We're a systems manager for a large company. What does the 5% represent? Boris, what is 5%? Well, we use the 5% to help us with the trials, but what does the 5% in the question represent, Jenny? Right, so the 5% means that they're bad CDs, okay? Because that percentage ends in anything other than a 0, what does that mean I have to do? I have to use double digits. What do you mean it's only 1? That doesn't matter, because the percentage doesn't end in a 0. So anything less than 10%, we're looking at double digits anyway. Okay, any percentage that doesn't end in a 0, we're looking at double digits at least. So that alone tells me that, okay? So how do I take double digits and assign 5% of them to mean bad CDs? What did you guys assign them to be? 0, 0 to 0, 4 would have been okay? Did anyone do it differently? Anyone do 0, 1 to 0, 5? If you did that, you would still have to ignore 0, 0, okay? Which is fine. So if I'm going, or I would have to make the 0, 0 be a good CD. So if 0, 0 to 0, 4 are the bad CDs, what numbers would represent the good CDs? 0, 5 to 99, okay? So 0, 5 to 99. That would be 95% of the double-digit numbers, and those are going to be the good CDs. Okay. So in our simulation process, we kind of skipped steps 1 and 2, didn't we? Let's take a step back for a minute. What would step 1 in the simulation process tell us to do? Identify, well, to restate the problem, what are we actually trying to do here? How many CDs, so what is a trial? A trial would be how many CDs I have to buy until I get 5 good ones. Okay? So I'm going to write that down. Okay? What's step 2? In the simulation process. Do you remember? The assumption. So that would be what? Every number that appears in the random number table has an equally likely chance of being selected. I agree. Step 3 is the assignment of digits. Step 4 is going to be the trials. So I've been given down here the random number tables that I'm going to use for each trial. So I'm looking to get at least 5 good CDs, right? So let's go ahead and decide. I'm going to look at double digits. So 0, 3 is going to represent what, a good one or a bad one? That's going to be a bad one, so I'm going to put a B underneath 0, 3. 2, 4 is going to be a good one. 2, 5 is a good one. 0, 6 is still a good one. 9, 2 is also good. And 1, 8 is good. I hadn't stop here after the 1, 8 because I've gotten 5 good CDs. How many did I have to buy to get 5? 6. So my outcome is going to be 6 CDs. Okay? Let's keep going with trial 2. April, tell me how many you get in this case. Let's label them. 7, 8 would be a what? Okay, keep going. 6, 9. Keep going. 5, 2. 1, 4. 0, 2. Okay, and then 8, 5. Okay, so I can stop after the 8, 5 because I've gotten 5 good CDs. Again, it took me 6. And then how about number 3, Karen? Help me out. What do I have here? 6, 0 is, okay. Don't I just have 5 goods all in a row? So it's 5 would be my outcome here. Okay, so those are the results of my trials. My final step is going to be the conclusion and context. So what is the conclusion here? What do I have to show? I've got to show some kind of calculation, right? So what is the calculation I want to do here? I'm going to do the average. So I'm going to do that. Good. I'm going to say 6 plus 6 plus 5 divided by 3. And what is that? 5.7. So we're going to say the words on average. I will have to buy. As a buy, or what am I doing with these CDs? I'll just say it will take an average of 5.7. Oh, I can't even write. What am I doing? It will take an average. Oh, it will take, I'll have to write average again. On average, it will take 5.7 CDs to get 5 good ones. Okay. So full simulation from beginning to end. Just like your simulation quiz. Did you agree? Nothing really more to it. All right, I'm going to pause the recording again. I want you to go ahead and look at question 14. 14 is an experimental design question. So if you'll look at questions 14 and 15, we'll talk about those in a couple minutes, okay? What I'm looking for here is a design. You're going to have to design an experiment on your test as well. So it's not going to be this exact question, but it will be an experiment nonetheless. What are the issues I absolutely have to address? I'm going to kind of list them over here. Okay, I don't have to address blocking in every single experiment, but in this one we will address it. So I'm going to go ahead and write blocking. Control, good. And what's the last one? So replication. I'm going to leave randomization at the bottom because it's going to be a little bit more complicated to address. So for my purposes, I like to just list those words out so that I know that I have to address all of them. And again, blocking is not always, it's a sometimes. Would you agree? I'm just listing it here because I know by reading the problem that I am going to block. What am I blocking by? The type of injury I had, whether my bone has been broken or whether it's been fractured. So I'm going to block by injury type. I'm just telling myself that's what I'm doing. Okay? I'm blocking by injury type. How am I going to use a control group? Or how am I going to address a control here? I'm going to administer some sort of placebo, or they're going to get no bone builder. Would you agree? It's one or the other. Not really sure. It doesn't really matter how you design it. How about replication? How is that addressed here? In each treatment group. Okay, so there are multiple subjects in each treatment group. And that would be, I think there's going to be 9 in each of the bone break groups, and there's going to be 15 in each of the fracture groups. Would you agree? Okay, so subjects in each treatment group. And then randomization I'm going to come back to because it's going to be a little bit more of a thorough discussion that we're going to have to do. So I am okay with you literally just creating a list, okay? You don't have to write it in paragraph form. Some of you prefer to write it in paragraph form. I'm not going to be picky, okay? If you just want to list them and explain how each of them are addressed, that's fine. They would be okay too, as long as you're addressing each of these, and then now we're going to start with my diagram. Now, the one thing that Katie asked, which I thought was a really good question, go ahead and ask it for everybody again. Okay. Is blinding something we should address here? It's not required because it's not one of the 3 required elements, but I think it's kind of an interesting thing to talk about here. Why so? Because if there's a placebo, isn't blinding kind of really important? Because you don't want to know whether you're taking the placebo or whether you're taking the bone builder. You should not know that information because there's something called the placebo effect. You might think that you're getting the treatment when you're not really, and you might think that your injury is better or whatever. So blinding would be something you could address here in the control group. I think that would be something that would be good. Okay, and we can say that we're going to use blinding. Would it be double blinding or single blinding? It would be single in this case. Okay? How could it be double blinding? Right, the person that's doing the examination of the bone doesn't know whether you had the bone builder or not. And that could happen too, right? Only the person that gave you the actual would know the difference. Okay? So that's where so that's something you could address as well. In this case, I would agree with you, Byron. I think that you're right. I think that you can't fake whether your bone heals better or not. I agree with you in this particular case. I'm talking about just in general. Yeah. Okay. All right. So let's go ahead and draw our diagram. Zachary, how did I start? What were my 2 blocks? The break versus the fracture. And how many of each did I get? Did I start with? How many breaks did I have? I had 18 breaks. And how many fractures did I have? 30. Good. Notice I put the numbers there. I think that's important. Okay? Now, how many treatment groups within each block am I going to have? 2. I'm going to have one that has the bone builder and one that has the placebo or no treatment. I don't care how you say it. I'm just going to write control here. So we have bone builder and control. What am I missing at this point? The randomization. Because this is where the randomization occurs, is it not? I have to randomly figure out of my 18 breaks which ones go into the bone builder group and which ones go into the control group. How many go in each group? 9, half of them. So I have to randomly assign who goes into what treatment group. And so in my diagram, this is where the randomization occurs. But I need to, so that's not enough to address randomization. I do need to explain that process, which is why I left myself some room down here to do that. Okay, it needs to stop. There we go. So how could I randomly assign? Let's start with my my 18 breaks. Let's pick a randomization process. How could I state that? What am I going to do? I can't just say I randomly assign. Tell me what you're doing. Assign them a number. What kind of number should we use? 9. We have how many breaks do we have? 1 through 18. Got to just my whole block. Okay. So we're going to assign my breaks, numbers 1 to 9, is it 18, sorry, 1 to 18. I'm going to go ahead and I could use 0, 1 to 18 if I wanted to use a random number table, but I'm going to use my calculator. So when I use my calculator, I don't have to worry about double digits, right? So I'm okay here. So assign my breaks 1 to 18. I'm going to say I'm going to use the random integer function of my calculator, and I'm going to say 1 to 18. And what's going to happen? I'm sorry, April? You can't say 1 to 9. You have to say 1 to 18 because the first 9 that appear are the ones that are going to go into my first treatment group. Oh, I'm sorry. That's what we're saying. That's right. But how are you assigning who gets 1 through 9? How did you assign the numbers? Where is the randomization? You see what I'm saying? Is it because I like you and you're number 1, so you're going to get bone break? Do you see what I'm saying? So by doing what you're saying, you have not introduced randomness at all. So you have to say somewhere where the randomness is occurring. Okay? So if I just say that everybody in the group gets number 1 through 18, use that random integer function, and the first 9 that appear, go get the bone builder. Okay? What am I going to have to worry about? Repeats. Because if they've already come up and I've assigned them to a treatment group, I can't reassign them, can I? So I'm going to have to say that. I'm going to say ignoring repeats. The remaining 9 do what? What are they going to get? The control group with the placebo. And then it is okay for me if you just simply say to repeat the similar process for the fracture group. That's okay. You can just, as long as you fully explain how you use randomization in the first block, you can just say, repeat that process for the remaining blocks. Okay? So we're going to repeat the process for the fracture block. Okay? Now, I'm still not, go ahead. Yes, and I would want that, something very similar to that on the test. Now, that's not the only way to assign randomization. I could use even and odd numbers. There's all kinds of different things I could do. But this introduces that idea of randomization, and it just is purely random of who goes into what group. I don't want to have any kind of favoritism. Okay? Now, the only part that I'm missing at this point is what? I'm only missing one more thing. The comparing. Now, how do I compare? Who do I compare to? So I'm going to compare within each block. You can write that sentence if you want, or you can put it in your diagram. So we're going to compare the treatment group to the placebo group within each block to see which one did better. Okay? That is a thorough answer. You've written out how you've addressed each of the 3, in this case 4, essential elements of experimental design. You've given a clear explanation of how you used randomization, and then you've diagrammed it out as well. I did. Compare. You can either or. You can either write a sentence and say compare the results within each block, or you can write it on the diagram. I would accept either or. That's not essential. You're really trying to compare the treatment to the non-treatment. Okay? If you're comparing within each block, that gets a little tricky because really a control group is just that, to compare. And the reason you're blocking is because you think that they're different. They're going to you're trying not to have a confounding variable. You don't want anything to get in the way. So you really should only compare within the blocks themselves. Okay? How do we feel? Feel like you got this one okay? Anyone do a pretty good answer on their own without us going over it? Feel pretty comfortable? If you didn't have a thorough enough answer, do you see where you had holes, where you needed to fill in? Okay, that's good. All right, the last question that I wanted to put on the recording is question 15. So take a second and read that if you haven't already. So in question 15, which of those two responses, A or B, do you think is going to give you a greater response or an increase in military funding, Cameron? What do you think? A. Why do you think A? Okay, so because of the wording of the question, it's going to force you into a certain response or persuade you to answer a certain way. And the phrase is better protected citizens. Wouldn't you agree? So what kind of bias is that? Response bias. So because of the phrase better protect its citizens, it's going to suffer from response bias. Good. All right, so I'm going to go ahead and pause the recording. Everything else, so again, the multiple choice was recorded already in block 2 this morning. And I'll go ahead and stop.